Hello and welcome back to another episode of Hacks. It's Byron speaking, and today we are actually trying to hack on the mandelbrot benchmark from the benchmarks game. The thing is that I think the code is pretty optimal, and the only issue I have with it is this, relatively hot loop here that will have a checked access to an array with initial values. And this happens all the time, and I think that's where lots of performance is lost, because besides that, there's not too much you can do to improve performance here. I mean, nothing that would matter or is more than a few, maybe milliseconds. The second thing that you can't really get rid of, but which could probably be make it closer or get it closer to C, is this pushing here, which always does a lot of checking, and we have pre-allocated the vector. We know it's big enough. Having a direct access here would probably be what you want, direct unchecked access, by the way. But on the other hand, just a few pixels in the end, and that probably doesn't matter, but this might matter. So I've downloaded the code. It's in mandelbrot.rust somewhere here. And I think first things first, cargo new. Let's make a project so that I can hack on it and run that thing. Cargo new mandelbrot bin. So now we have a subfolder here. Should have a main in there that we can just override with the mandelbrot Rust implementation. There we go. And now cargo run release should already run it. Let's see how it's run. 16,000. And then I think they write some sort of file here. It's a ppm file, I think. So let's try that. Let's see. Oh yeah, and let's time it. What? Did I future spawn? That doesn't really look rusty to me. Oh, it wants to have, that's amazing. It wants to have nightly, it seems, huh? Or, I mean, this is a different version of the mandelbrot algorithm here. Yeah, because that's purely functional. Look at that. Is it? Is this the same thing I see here? That was unexpected, because this was creating a struct here that was actually pretty neat. It was pretty rusty, I think. Whereas this one here is totally different. So what does the header say? Contributed by Rodrigo Corsi. Whereas this one here is contributed. Yeah, let's actually open it in Sublime Text for a moment. So that does indeed want to have Rust nightly, huh? This experimental stuff. Come on, is that really needed? Future spawn. And what's future spawn anyway? I don't know. Is this better than using threads? Probably not. Sync future. Deprecated. No, wait. That's not deprecated. Spawn. Deprecated since 1.2 implementation does not match the quality of the standard library, and this will likely be prototyped outside in crates.io first. Okay. So why did I get this version that seems to be newer than anything else? What the heck? And this will not be included anyway. That's deprecated. Will go away. Well, fine. Then I might just have a look here to see how it's done. Maybe it doesn't do these accesses anymore. Of initial values. back in it. Huh. That looks very different, that's for sure. Look at that. But it also changes the algorithm, does it? Looks like it. Previously, the Go and Rust version looked very, very similar. And probably thanks to the different algorithm, there is a benefit here. And it uses SIMD instructions. Yeah, so anyway, I don't know why I got this. Maybe there are different versions. What the heck? Mandelbrot dot... Are there different versions here? No, there's just one. Okay. I will use that one then. And yeah, maybe there's also a link to the file itself. That would be very nice. But not that I would see here. Okay. Well, that works well enough, I suppose. Cool, so that should actually work. Let's try again. That's just the first run. And it definitely is running, that's for sure. Good. So it takes 25 seconds on all my cores, so 4 seconds total. That's not too bad. It uses double precision as well. So something I would change, but that will not affect the performance at all, is this. Why not have an array of nums here? So is this automatically usize? We will see. We'll also see if that still works, but it should actually. Actually, cargo check is made for this. Cool. Now the actual thing is this one here. Here we want to have get unchecked. And wait, let's have a look. I think this might even return an option, but no, it shouldn't. Get unchecked. Here it is. So you need a slice to make that work, and it will return the thing directly without putting anything around it. So that's as clean as it gets. Self initial R. Yeah. Let's see. So right now it doesn't like it. To take value of method get unchecked. Oh yeah, sure, sorry, sure. That makes no sense indeed. Also, we will need unsafe code here. Mismatched types, right. But so far this works. Now it will tell me I need unsafe code. Yes, we will do that. Let's adjust this one as well. Get unchecked. And I'm curious. I think this will definitely improve performance here a tiny little bit. Because really, this is such a huge, it's kind of, sure, it's safe, right? But people tend to forget or don't know that all the accesses are checked, so there's lots of overhead involved with that. Cool, so that worked now. Let's see what the time says. Yeah, and we might want to run this a few times. So that was the compilation time that was in there. 3.8. So now it, for all the cores at 24 seconds, 25. Did that improve anything? "25 seconds. Now, basically, we are now below 4 seconds for the user elapsed time, but I don't think that anything improved here. That's sad. Yeah, something I find sad as well is that there's basically no easy way to submit code to this computer language shootout because it doesn't use GitHub. And if it would use PRs, honestly, it would be so much easier. But you have to kind of log into some other system, then create an issue where you attach your patch file. I mean, I can make patch files, no big deal. But I don't like to use a new system for that, something that is quite uncommon for me, at least. So I usually don't do it. So this kind of fix I would definitely submit right now, just for the fun of it, but not with all that process overhead that goes along with it. Yeah, well, let's see. Let's undo this. Oh, actually, let's try to get it into Git real quick. If it's not yet in Git, is this Git? Yes, it is in Git. Git add. So I will just add this one. And now let's undo this. Very quick, I think that can stay. And let's see if the timing changes visibly. If it doesn't change visibly, then, well, the answer is that probably it's just not hot enough in there. Yeah, doesn't change at all. Damn it. Good. I mean, last time I did that, I was hacking on falling sand, and it improved the performance manifold, right? But it would do a lot of accesses all the time. Yeah, so what I see here is just the random factor here. Of course, the code previously was better, considering it's not that hot after all. We are good. And I think that hack is for nothing after all. Fail. But that's how it happens sometimes. Thanks for watching, and have a good day.